Think Newton discovering the law of gravity, Rutherford splitting the atom. A science discovery announced today is big. It's Big Bang Theory big. The Higgs Boson particle could tell us what gives all matter in the universe its size and shape. They found it after smashing atoms together in the Hadron Collider. Right there, and the energy that was released was the so-called God particle. But believe it or not, I am no quantum mechanics expert. Let's hand over to a super brain to explain.
We have this machine which accelerates protons in two different directions. They slam together, creating 14 trillion electron volts, temperatures and energies not seen since the instant of the Big Bang. When these two beams of protons collided, a fantastic energy, a spray of subatomic particles. Then we run the videotape backwards. We run it backwards to find what particle existed at the very instant of the collision. The Big Bang Theory simply says the universe expanded 13.7 billion years ago. But what put the bang in the Big Bang? Why did it bang? What is the energy that drives the Big Bang? The Higgs particle could have the key to this whole cosmic puzzle.
Well, we've got our own in the big brain department, of course. Experimental physicist Mark Kruse is at a quantum physics conference in Melbourne. Now, he's a Kiwi, but he's been part of the Atlas team at CERN doing work on the Higgs Boson. Hey, look, thanks for joining us. Are you as excited as everyone else about this?
I'm completely thrilled. I mean, this is something that I've been involved with now for more than a decade, and it's really the culmination of a huge amount of work from a huge amount of physicists, and it really is an extremely exciting moment in high-energy physics.
I was sort of thinking, we're talking about this today, I suppose if it was music, it'd be like being in the Beatles and you just brought the White Album out.
Well, yeah, maybe. I mean, it's even more than that, I think, because this is really just the beginning of a whole new era of exploration, and we don't know that we've actually found the Higgs boson yet. I mean, we've certainly discovered something. There's something there. Both the main experiments at the Large Hadron Collider are definitely seeing something. They're seeing it in the same way, and it'll take a little bit more time to determine if it is actually the Higgs boson. But if it is, then it's not just the discovery of a new particle, it's the discovery of a whole new fundamental nature of all of space, and that is that it's filled with this Higgs field, and how particles interact with that Higgs field is what we call the Higgs mechanism, and that's what actually gives particles mass.
Are they going to have to rip up all the
texts? It's an extremely exciting time.
Are they going to have to rip up all the textbooks, start again?
No, and in fact, it depends what textbooks you're reading, of course, but it's really just adding to the textbooks. I mean, the textbooks now have the so-called standard model of particle physics in them, but the standard model was missing this piece of how fundamental particles, how mass is generated for these fundamental particles. And so this discovery explains that. So it's basically just an addition to the textbooks. Now, if the standard model is broken down somehow, and there's good reasons to believe that this is actually part of a much grander theory of the universe that we just have no access to right now, if that is true, then that will certainly rewrite the textbooks.
Look, once upon a time we thought atoms were the sort of smallest bits of the whole equation. As technology and science progresses, we seem to be drilling down further and further more. In another 50 years' time, will someone be sitting in our respective seats talking about, you've taken another step, or is this it?
It's definitely not it. I mean, it is certainly a big step. It answers one of our most fundamental questions, but there's a huge number of other even more fundamental questions. What we're doing now at the Large Hadron Collider, we're probing what the universe actually looked like about a trillionth of a second after the Big Bang. But even before that, there's things that we just don't understand how they occurred the way they occurred. And really, this is just the beginning, and there's a lot more fundamental questions. We really still know very, very little about how and why the universe evolved the way it actually did.
Well, keep on working at Professor Mark Kruse. We appreciate your time tonight. Congratulations on being involved in something so shattering for the scientific community. And Mark is giving a public talk called Why We Care About the Large Hadron Collider at Auckland University on July the 12th. It's free, and the details, we're going to have them on our website.